Okay, so we've been dealing with these trig functions and solving missing parts of triangles. We talked about angles of elevation and depression a little bit yesterday. I want to look at some more aspects, uses of these right triangles. The toughest part of dealing with using trig in real life applications is finding right triangles. And as we saw yesterday with our angles of elevation and angles of depression, one place where we can find right triangles is if we have vertical and horizontal components. For example, if we're looking at the ground, which hopefully is mostly horizontal, and a pole that, if done correctly, should be vertical, we can create a right angle between those two. Another spot where we can form right angles, because the first step in making right triangles is, of course, to have a right angle to begin with, is looking at circles. I don't know how much you got into for circles last semester, but one of the basics of circles is if you have a circle and you have a tangent to that circle, remember a tangent touches the circle but never actually contains any points inside the circle, just contains that one point on the circle. A radius of that circle that goes to that point of tangency is going to form a right angle with that tangent. So there is another place to find right angles. It's another potential source of right triangles for us. So we're going to take a look for, and of course, a third source is just map directions. Map directions or compass directions, however you want to put it. Obviously, east is going to form a right angle with north, and so on. Vertical and horizontal. Got her? Okay. So let's say that Mike here decides it's time to escape. Now that his friend has made it home in the boat, Mike decides he doesn't want to be home anymore. So he jumps in a boat and he goes straight south, due south, 40 miles. And then turns and heads due east, another 9 miles. We want to know how far is Mike away from the dock. This is the dock, of course. And at what angle? Now, the angle we're going to ask for is this angle right here. How would we find that distance? Well, first of all, where is our right angle? Bottom left corner here, between the 40 miles and the 9 miles. So we have a right triangle. That's our first requirement. Our second requirement is we have to have at least one side. We have to have two other parts, and at least one of those parts has to be a side. Here we have two of the sides. If we have two sides and we're looking for a third side, what do? Pythagorean theorem. And I'm going to use a shortcut, which is going to look like this. This side is going to be the square root of what? 40 squared plus 9 squared. Right? Those are both legs, so we're adding them together. Ends up being 41. Then we need to know the angle here. According to that angle, what two sides do we know? 40 is the adjacent and 9 is the opposite. So that is what trig function? Tangent of an angle is opposite over adjacent. So the tangent of our angle, opposite is 90, adjacent is 40. And since we are looking for an angle, we use inverse trig. It'll be tangent -1. So second tangent, 9 divided by 40. 12.68 degrees. Not so bad. So there we're using compass directions. South and east have to be at right angles to each other. We might use something like this. Let's say that for hauling a spool of wire, we have a frame that sits in the back of your truck. Now I realize this is kind of, I'm going to spread this out a little bit more. My drawing's a little horrible there. There, like that. Now I simplified this frame a little bit to make it easier to deal with. It comes down to a point. Most of the time there would be a flat portion on bottom, but it's simpler if we make it come to a point. This height here is 36 inches. Let's say this height here is going to be 4 inches. This angle, I'm going to make it 110 degrees. And our spool of wire or cable or whatever, let's say it is a diameter of 48 inches. Looking at this, where am I going to find a right angle? When I have a circle, I look for tangents. So the radius to this point of tangency makes a right angle. It'd do the same thing over here at that point of tangency. It'd make a right angle. Now, if my drawing wasn't horrible, these would be the same on both sides. This distance here and this distance here would be the same. In fact, we can cut it like this, right down the middle, and it cuts that exactly in half. So this angle here is going to be how much? 55, half of the 110. So I'm going to redraw that triangle over here. This is 55 degrees. Are there any other pieces I know about this? I know the right angle. So I have 2 angles. In essence, I have all 3 angles. What side do I know? I know this side right here. How do I know that? It's half the diameter. It's a radius. That should be 24 inches. So from that, I can figure out what I want to know here is I want to know how high this sits up. So I want to know if it's sitting on the back of the truck, if I'm going to have problems getting under overpasses and stuff like that. I want to know how tall this is. So that's going to be my X. So I'm going to find this height right here. This side, I'll call it side, well, C would be the appropriate label for it. And if I'm going to commit to this angle, the 55-degree angle, come on. What side do I know? The 24 I know. What side of the triangle is that? That's the opposite side. And I am looking for side C, which is the hypotenuse. Opposite and hypotenuse make sine. So I read out my definition of sine, and then I plug my numbers in. Do I know the angle? 55 degrees. Do I know the opposite side? 24 inches. Do I know the adjacent, the hypotenuse, I should say? That's C. That's what I am looking for. Put that over 1, and now I'm going to cross multiply. 1 times 24 is 24, divided by the sine of 55. I get 29.30 inches. Well, that is the distance from here to here, right? And then from here up is also going to be 24. You're correct. And I also have the 4. So that is what? 2857.30 inches. That is found just by adding 24, 29.30, and 4. Not so bad? Yes, sir. So that's this here. That's this piece here. Yep.
What was it? 27.30.
29.30. That one, that too.
Heck, why don't we do stuff like that?
What's that? The graphing? That's from my high school class.
Yeah. They can do ours and we'll do theirs.
Oh, let's see, what do I want to do here? Oh, let's have some fun. I'm going to make this easy on myself and draw the circle first. So I want to draw this. I am going to tell you that the diameter of my circle is, well, let's say it's 40 feet. And I'm going to tell you that this angle right here is, let's go with 130 degrees. This is a right angle. I want to know that distance. So the question is, how am I going to get there? I'm also, since we're having fun, we're going to find that one too. Why not? No extra charge. Well, where am I going to find right angles here? We have one given here. There's a right angle, because that's a tangent to the circle. There's a right angle. Do we know this angle here? We do. Actually, not quite, I don't think. This is a 5-sided figure. The angle sum, remember triangles have 180 degrees for their angle sum, right? They add up to 180. It's n minus 2 times 180. So this has 5 sides, so n would be 5. So it's 5 minus 2 times 180, which would be 540 degrees. 5 minus 2 is 3 times 180. So we currently have 90, 90, 130, and 90. Which is what, 400 degrees?
Wait, no, never mind.
So 540 minus 400 is 140. This is 140 degrees here. Well, why is that important? Well, we know that this is 20 feet. This is 20 feet. I can cut this across here and I make a right triangle. Do I know anything about this angle right here? No, I don't. But I do know this angle right here is how much? Actually, I don't know anything about that angle, do I? That ain't going to help us much there. I was supposed to tell you that this lines up with the center. That's what I was missing. I did. That's supposed to be 20 feet there too. So now we can find this angle. Why? Well, if this is 20 and this is 20, right? These two are both right angles. Then I know these two better be right angles. So that tells me this angle here is 50, 140 minus 90. This angle here is 40, 130 minus 90. So all we have to do is find this side, and that side will be the same as this here. So how do we find that side? Which angle are we going to commit to, the 40 or the 50? Sounds like you want the 40. So I'd make the 20 the opposite, and this is the hypotenuse. So yes, we are dealing with a sine. So we'll plug in the angle, 40 degrees. Opposite side is 20 feet. We are looking for the hypotenuse. Put that over 1. And now we're going to cross multiply and divide. So 1 times 20 is 20, divided by the sine of 40. So that's 31.11 feet. Is that my solution then for dimension x? Say no. No. This is 31.11 feet. The red piece, I still have to go out here. How much is that? Where did the 20 come from? Yeah, half the diameter of 40. So this is 51.11 feet. A similar problem would look like this. So we have a half circle. Pretend that looks round. We got a tangent. Let's say this out here is 8 feet tall. That circle has a diameter, let's say, of 40 feet. Let's keep it simple. Let's make it a diameter of 24 feet. The slope of this is we're going to say it's called a 412 slope. I want to know what's the length all the way across there. What's that distance all the way across? So I can find a right angle here by drawing that tangent in, or that radius to the tangent. And I know that that radius is 12 feet long, right? Half of my 24 diameter. I know this has to be a right angle. Do I know any of those other angles? Right now, I do not. But I can find a right angle right here. This wall has to be vertical, so I'm going to cut this across here horizontal. That makes a right angle with a vertical. That means I can find this angle here. How can I find that angle? Because of this aspect ratio, that 4:12 slope. I can look at it like this. As a triangle, where this side is 4 and this side is 12. So this angle here is going to be an inverse tangent of what? What's the opposite side? 4, and the adjacent side is 12. So second tangent 4 divided by 12 should be 18.43 degrees. So what that does for us, I'm just going to go ahead and cut this here. I'm going to cut this straight down to make a right angle here. So again, I have vertical and horizontals that intersect to make a right angle. So what I know here is I know that this distance from here to the center is 12 feet. I am going to find this distance, this piece here, and this distance, which is this piece here, which is going to be the same as this piece up here. Make sense? No? Not good? The hard part is seeing that you'd cut it up into those triangles.
Where did the 12 and the 4 fit in?
Well, up here, the 412.
Yeah.
The 412 is considered a slope factor, an aspect ratio. That's saying is there's, for every 12 units of run, there's 4 units of rise. So that's what we use to get that slope angle.
Okay.
That's a construction abbreviation, construction notation. So right now, the only triangle I have that I know much of anything about is this one right here. I know this is my radius of 12 here. I know that's a right angle. I can find that angle. How? I'm going to go back out to this figure here. How many sides does that have? 4. I know this is 90 degrees and this is 90 degrees. This angle here is 90 plus 18.43. So that angle, that whole angle there is 108.43. Make sense? Being a 4-sided figure, 4 minus 2 times 180 has to have a total of 360 degrees. So that makes this 71.57 degrees here. Now that I have that, I can find this distance here. I'm going to call that A, and this distance here I'm going to call B. A is the adjacent side. I have the hypotenuse, that's going to be sine. Sine of 71.57 degrees equals A over 12. Put this over 1, cross multiply and divide. Did I say sine? That's not going to be a sine, is it? That's going to be, A is adjacent, so it's going to be cosine. So 12 times the cosine, 71.57, is 3.794 feet. So this is 3.794 feet here. B is going to be found the same way, only it's going to be sine for B, because B is the opposite side. So sine of 71.57 degrees equals B over that 12 hypotenuse. Put this over 1, I cross multiplying, oops. I'm going to cross multiply this way and divide by 1. So 12 times the sine, of 71.57. 11.385. So that tells me that this distance here is 11.385. How does that help me? Well, I subtract off the 8 here because this is going to be 8 as well because that's a rectangle. That leaves me with this distance being 3.385 feet. Does that make any sense? So subtract the 8. Now that I have that as 3.385, I have that triangle up there, 3.385, and this was 18.43 degrees. That's this triangle here now. That one. So I'm going to find the bottom of that. Down here, that's going to be the adjacent side, that's tangent of 18.43 degrees equals opposite of 3.385 over that adjacent side of D. Make it a proportion and cross multiply. 3.385 divided by the tangent of 18.43. 10.158 feet. Well, that is this distance here, which is this distance here. So now to find that total distance across, I add my 12, 3.794, and 10.158. So let's see, what do I get there? 25.952 feet is my distance. Not so bad? I most likely would not be quite that harsh on you on a test. Just saying. Most likely. Another example that I want to show you. Just because it kind of has some application for you guys. Is on a globe. Angular distance. With GPS right now, it's pretty easy to get longitude and latitude. Latitude is your distance from the equator. It's actually your degrees from the center of the Earth from the equator. And longitude is your degrees from the prime meridian. Prime meridian runs between Russia and Alaska, and then it runs through London on the other side of the Earth. So every location on the globe has a longitude and latitude reading. Like, I don't remember what our longitude is here, but I know our latitude here is like 48 or 49 degrees above the equator. So I'm just going to make up a longitude. Let's say our longitude is 39 and our latitude is 48. Now, usually that would be divided down into degrees, minutes, and seconds. This is about the only application I've ever seen them use seconds effectively, is for longitude and latitude. Because the Earth is big enough that you can distinguish, you know, a couple of steps one way or another is a couple of seconds of an angle. And it is longitude first, latitude second. So let's say we need to run a cable from where we're at, 3948, to Florida. And we're going to run exactly straight, but we're going to go at the surface of the Earth or just below the surface of the Earth. And let's say Florida is let's see here. I'm going to call it 4319 for longitude and latitude. The distance between them is found trying to remember how this formula works. Sine of L1, L is, it's usually L and then M is how they're listed. So L is longitude 1, M is, you call it latitude 1, meridian 1. Sine of L1 times the sine of L2 plus the cosine of L1 times the cosine of L2 times the cosine of M1 minus M2 is the angular distance. And what that's going to do is that's going to give us an angle between them. I'll show you how that'll help us out a little bit. So L1 we said was, let's just write them here. 3948 and 4319. So this is L1, L2, M1, M2 here. So sine of 39 times sine of 43 plus cosine 39 times cosine 43 times cosine 48 minus 19. So sine 39 times, oh, and I forgot to put in here that then it's a, this is the cosine over here, so we have to do an inverse cosine when we're done. So anyway, sine of 39 times sine 43 plus cosine 39 times cosine 43 times cosine 48 minus 19 gives us that decimal. We do an inverse cosine of that then to get our angle for our distance. That tells us the angle is 22.13 degrees. So what we're looking at is if we were looking at a circle, the angle from the center of the circle is 22.13 degrees. Which means all we need to know is the radius of the Earth. Anybody know the radius of the Earth? No? Sorry. The radius of the Earth is about 8,000 miles. It's about 8,000 miles. I can look it up exact. Why not? We've got a minute. Radius of the Earth. Sorry, the diameter of the Earth is about 8,000 miles. Radius is 3959. So knowing that's 3,959 miles, we can then find that distance. Because we know that the circumference of the whole circle is pi, 2 times pi times 3959. So the arc length, did you guys talk about arc length at all last semester? The arc length is the circumference of the circle. So it's that 2 times pi times 3959. So let's just call it 24,863 times that angle of 22.13 over 360 for the whole circle. So So that's 1,526 miles. Would be the angular distance. It would be the actual surface distance between those two coordinates on the globe. Does that make sense? Kind of? Okay. In your packet, the old Smith packet, the one we've been working on, page 720, exercise 35-2. There's 1 through 17 there. Just want to do the odd or define. And page 731, exercise 35-3. 1 through 15, if you just want to do the odds there, that is also fine. Those are some pretty complex applications, and some of them, especially the 731 ones, are pretty tight. There's some tough ones there. And I will hand out your test for you. Did Andrew want one of you guys to pick one up for him? Okay.